All right, so we have significant figures. And the first thing we want to be able to do is just look at a number and determine how many significant figures are in that number. So determining, and you'll see me put this a lot now, sig figs. All right. So determining sig figs. So when we get a number to look at and try to determine the number of significant figures, the first thing we do is we look for any non-zero digits. So non-zero digits are significant. All right. So any number 1, 2, 3, 4, 5, 6, 7, 8, 9, all significant digits. All right, so really easy. If it's not 0, it's significant. What isn't as easy is doing actual zeros. So zeros, we have some different types. All right. The first type of 0 we can have is called a leading 0. All right, so a leading 0. With leading zeros, that means they have no non-zero digits to the left. So if I start out by looking at the number and I look at a 0 and there are no non-zero digits to the left of it, then we call it a leading 0. And these things are never significant, so we do not count these zeros. Let's make that a star, so because that's important. Never significant. The next type of 0 we call a middle 0. Sometimes they call it a sandwiched 0. Okay? So middle zeros, they have non-zero digits. Somewhere, let's put that where in there, that's important. Somewhere, maybe not directly next to them, but somewhere to left and right. And the thing about middle zeros is middle zeros are always significant. Okay? So easy enough. So far, we know that any non-zero digits count as significant figures. We know that leading zeros, so if we look at a number, these are the zeros like would be before any non-zero digits. Those are never significant. If we have zeros that are in between non-zero digits or middle zeros, they're always significant. We always count them. The trickiest of these types of zeros is the trailing 0. So a trailing 0 means that there are no non-zero digits to the right of them. Okay, so they're at the end. They're trailing. There's no non-zero digits after them. Now, these are only significant if there's a decimal in the number. So if there's a decimal in the number somewhere, then we count them. If there's not a decimal in the number, they do not count. So this first part under the box, if you're looking at the worksheet I gave you, see the big box, which basically has the rules that I just told you to write down for notes. Let's look at number 1. It says determine the number of significant figures in the following numbers. Number 1, which says 0.02. All right, now first of all, and this is an important point, whenever you have zeros together, they're the same kind of zeros. Okay? So these zeros that are grouped here, I know first of all that they are going to be the same type of zero. Now just looking at this number, if I'm trying to determine the number of sig figs, the first thing I do is look for any non-zero digits and kind of mark them somehow, like maybe put an arrow up at it. All right, so I know the 2, since it's not a 0, is significant. That's automatic. If it's not a 0, it counts as a significant figure. I got to figure out, like I said, these are grouped here, so they're the same kind of 0. What kind do you think they'd be? A leading, a middle, or a trailing? How many people think leading? Raise your hand. Nobody thinks leading? How many people think middle? How many people think trailing? The answer is leading. Okay, with leading zeros, there are no non-zero digits to the left. There's no, if I go left to right, are there any non-zero digits before these zeros? No, they're in the front of the number. They're leading. As I go left to right, they're in the front. They're leading. All right? So those never count. So I am not going to count those. So this number here would have just one significant figure. Right. So if I look to the left of them, is there any number 1 through 9 to the left of them? If the answer is no, then it's a leading 0. It's at the front of the number. It's leading. All right, so let's look at number 6. 6 has 5,000. And what's important here is it's not just 5,000, but it's 5,000 point. All right, so first thing we do, any non-zero digits in 5,000, they count as significant, so that means the 5 is significant. These zeros are all grouped together, so they must be the same kind of 0. Are they a leading 0, are they a middle 0, or are they a trailing 0? Trailing, they're at the end. Okay, there's no non-zero digits to the right of them. They're at the end of the number. They're trailing. Okay? What is the rule with trailing zeros? You just wrote it down in your notes. Anybody want to share? Only significant if there's a decimal point in the number. Is there a decimal point in this number? Yes, there is. So that means they are all significant. So this has a total of 4 significant figures. Take a look at number 5. Yeah, I'm just using the arrows to mark the significant figures. So 5 is the exact same number, but with no decimal point. So again, 5 counts. These are all grouped together, so they're all the same kind. They're still trailing zeros, right? Trailing zeros only count if there's a decimal point in the number. Well, in this one, there's not a decimal point. So they do not count in this data point. All right, so they do not count. There's just 1 in that number. One other one I want to point out. So we look at number 10. It's 10,001. Okay, so I know the 1s are significant. These zeros are grouped together, so they're all the same kind of 0. What kind of zeros are they? Middle zeros. Middle zeros always count. So that actually has 5 for number 10. So that's the reason why I show you that is because I don't want you thinking that in order for it to be a middle 0, it has to have a non-zero digit directly to the left or right. No, just somewhere to the left and somewhere to the right of it, there's a non-zero digit. Number 4. Sure. So number 4 is 501. point 0. So significant, significant. What about that first 0? What kind of 0 is it? It's a middle 0. Those always count. What kind of 0 is this at the end? Trailing. Trailing counts if there's what? A decimal. Is there a decimal in this number? 4 significant figures. All right, so in the bottom part, what we're doing is we are doing some rounding. And now I know some students in here, believe it or not, don't know how to actually round numbers. So I'm going to go over this. All right, if we look in the bottom section and look at number 1, it says 8,040. Oh, I'm sorry, we're not rounding yet. 8,040. All they want you to do here is just identify the last digit that is significant. And they have a blank, so we might as well rewrite the number. But so if I look at this, is 8 significant? Yes, it's a non-zero number. Is this 0 significant? Yes, it is. It's a middle 0. Is the 4 significant? Yes, it's a non-zero number. Is the last 0 significant? It is not, because it's a trailing 0 and there's no decimal point in the number. So that means my last digit that is significant in that number is the 4. So I'd put a bar over it. They want you to put a bar over it to show it. All right. Let's look at number 9. 9, they're trying to scare you with some scientific notation. Oh, where'd my 3 go? Oh, there it is. All right, so when we do this, the times 10 to the 21 part is just there to tell you that this is actually a really big number. We use scientific notation when we have these really long numbers where we'd have to use a bunch of zeros. And rather than make these really long numbers that have a bunch of zeros in them, we use scientific notation. So really what this number is it's 301 followed by 19 zeros. It's a big number, okay? But that doesn't matter. The times 10 to the 21st, that's just there to scare you. If you want to pick out significant figures, just look at the front number, just like normal. Is the 3 significant? Yep. Is the 0 significant? Yep. Is the 1? Yep. That's my last significant figure. So, like if you look at number 5, so they have 0.90100. So they're saying, okay, what's the last number that's significant? Now that front number is not significant, right? The front 0 is not significant. That's a leading 0. They never count. But just continue on. So the 9 is, this 0 is, this 1 is. These are trailing zeros. Do they count here? They do. Why? Because there's a decimal in the number, so they do count. So that's my answer to number 5. All right, so let's flip over to the back side. I'm just working my way through. See, now technically this is not significant, but there are more to the right. It's just kind of a placeholder is all it is. Yeah, rewrite it. So just rewrite the number on that blank they give you. I mean, really, could you just put a bar over the number? I don't know why that 0 is not writing. But no, don't do that. Come on. And we're back. All right, so on the back side of the handout, so we have part A. I'm not going to go over that again. That's just like on the front. You're just saying how many significant figures are in those numbers. But let's look at part B, because part B is where we have some rounding. So this is the back side of the handout, and this is section B. And so we have, let's look at number 21. Okay, so number 21 says 5.67. And what they do want is they want you to round this off to two significant figures. All right, so here's how we do it. Two significant figures, I'm just going to start from the beginning. I'm going to find where the second significant figure is. So starting from the left, is the 5 significant? Yes, it's a non-zero digit. Is the 6 significant? Yes, it's a non-zero digit. So that's my second significant digit. I'm going to round off there. When you round off, what you do is you look at the next number, and if it's 5 or higher, we round up. If it's 4 or lower, stay where you're at. So in this case, what should it be? 5.7. Are there two sig figs there? Yep. Let's take a look at number 23. So on number 23, they give me 304.1. And they say, round that off to three significant figures, please. Oh, okay. Is it 3 significant? Yes. Is this 0 significant? Middle 0 always counts. 4? There's my third one. So I'm going to round off at the 4 there. I'm going to either round this off to 304 or 305. What do I round it off to? 304. Why? The next digit is 4 or less, so keep it there. All right, don't round up. If it's 5 or higher, round up. Take a look at 25. Okay, 25, big number here. 25, we have 221.351. And it says round off to 4 significant figures. So are any of these not significant? They're all significant. They're all non-zero. So there's 1, 2, 3, 4. So I'm going to be rounding off here at the 10th place. Am I going to make this 221.3 or should I round up to 221.4? The next digit is a 5, so I'm going to round it up to 0.4. Okay, now we're not doing too much with scientific notation yet, and they give you some tricky ones here. So I'm just going to give you the answers. If you're curious about them and want to discuss them more, feel free to come up and go over them with me later. But the first one is 40,001, and it says round it off to 3 sig figs. All right. That means this is significant, this is significant, this is significant. I'm rounding off to the hundreds place. I'm either going to make it 40,000 or round up to 40,100. I'm going to keep it at 40,000. But the problem is, if I write down 40,000, that's not the answer, by the way. So if I write down 40,000, how many significant figures are there in that number? Just one. What if I put a decimal point at the end? Now there's 5. Neither of those answers is 3. The actual answer is 4.00 excuse me, times 10 to the 4th. And then 34 is a similar type problem. So 34, they say 3,000.34. And they say round off to 2 sig figs. So here's the first sig fig, here's the next. So I'm going to round it off to the hundreds place, either keep it at 3,000 or go to 3,100. All right, the next digit's a 0, so I'm going to keep it at 3,000. But that doesn't work either. So the actual answer to that would be 3.0 times 10 to the 3rd. So pretty good so far, right? Can I see thumbs? Thumbs up if it, yeah, this is making sense. Thumb sideways if it's kind of like, and thumbs down if it's, huh? Thumbs? I see some people without thumbs, thumbless. Which one? So this then. All right. So if that wasn't tricky enough, let's make it a little more complicated. And I said in the learning targets, the actual thing, the computations, the adding, the subtracting, the multiplying, the dividing. Well, here's the rules on those. So make sure you have this in your notes. Adding and subtracting, probably not as important to us as multiplying and dividing, but I want to go over it. So with adding and subtracting, look for, and this is not the best definition or even completely accurate, but this is how I explain it. Look for least decimal places. This is the key on adding and subtracting. It's about the decimal places, and the answer should have same. Okay, answer should have the same. So this is how this works. All right, we look at number 41. And I like to put these vertical, a little easier to see. I like to line up the decimal points. So on 41, we have 0.085. And then we have 0, we're going to add to that, 0.062. And then we're going to add to that 0.14. So I can start out by just doing the computations normally, just add them. All right, so add down this third column here, or third decimal point. 5 plus 2 is 7. 8 plus 6 is 14, plus 4 more is 18, so I'll put an 8 and carry the 1. 1 plus 0 is 1, plus 0 is 1, plus 1 is 2. There's my decimal point. 0 plus 0 plus 0 is 0. Okay, so I start with that. Now with adding and subtracting, like I just said, it's all about the decimal points. It's all about what's the smallest value the measurement goes to. So this first measurement, whatever we use, whatever measuring device we used, goes down to the thousandths place. And the second measurement we made, same thing, goes down to the thousandths place. But whatever we used for the third measurement wasn't as precise. It only goes down to the hundredths place, which really means that the smallest mark on that measuring device must have been the tenths place, right? Because we estimate one spot further when we record our data. So what this means is that since I don't have a mark here in this third decimal point, that my answer should only have 2, just like the 0.14, because that has the least number of decimal places, the least precise measurement. Now, for my final answer, I'm just going to round off there. So my final answer should be either 0.28 or 0.29. Which one do you think it is? 0.29. Why? 7 is 5 or higher. That means round that up. Okay? So 0.29 is technically the correct answer with significant figures. Let's do a subtraction one real quick. Let's look at number 44. So 44 says 145.63. And we are going to subtract 28.9. Can you tell me right now how many decimal places my answer should have? So you can tell right here that the answer is going to have 1 decimal place. But I'll start by doing the normal subtraction. 3 minus 0 is just 3. 6 minus 9 I can't do, so I'm going to borrow from here. Make it a 16. 16 minus 9 is going to be 7. There's my decimal point. 4 minus 8 I can't do, so I'm going to borrow from here. Make that a 3. Bring a 1 over here. So 14 minus 8 is 6. 3 minus 2 is 1. 1 minus 0 is 1. So there's my unfinished answer. And you guys said we should have 1 decimal place for the answer. So we're going to go 116.7 or 116.8. Okay, so adding and subtracting is all about the decimal places, or what's the smallest value of significance, really. Lowest value of significance. Now, with multiplying and dividing, it's actually easier, which is good because this is the one we'll use more often. So this would be at the very bottom, 63 to 76. With multiplying and dividing, instead of looking at the decimal places, it's all about those sig figs. So whatever has the least number of sig figs in the problem equals the number of sig figs in answer. All right. So it goes like this. Number 63. I have 17.3 times 6.2. Let's start by just multiplying that. So 17.3 times 6.2 equals 107.26. All right, now I got to check sig figs. The number 17.3, how many sig figs does that have? How many? 3. The 1, the 7, the 3, they're all significant, so that has 3 significant figures. How many does 6.2 have? 2. What's lower, 3 or 2? 2. So my answer should only have 2 significant figures. Oh, so this is where we're going to round again. How do I do that to 2 significant figures? Well, here's the first significant figure. Here's the second significant figure, so I need to round off there. Okay? So I'm rounding off at the tens place, which means I'm either going to round it off to 100, where it is right now, or round it up to 110. Which one should I do? Go up to 110. Why? Yeah, the next digit is 5 or higher, so my answer is going to be 110. Do I keep it as 110, or should I put 110 point? How many people think just leave it? Raise your hand. Then only 4 people are right. Good job, you 4. I should leave it because according to this, I got to have 2 significant figures in my answer. How many do I have? 1, 2. If I put a decimal point here, how many do I have? Now I have 3. Because I rounded this, the second significant figure. Because I know that the answer has to have 2. Okay, so when I'm trying to figure the significant figures, just do my math. Find out how many significant figures are in each number I'm using in the problem. And whatever one's least, I want my answer to have that many significant figures. So it's going to have 2. So, right. So, okay, because what we're rounding off to, so when I figured out I got to have 2 sig figs, go to the second significant figure, which is the 0. So I'm either going to keep, and it's in the tens place is the thing. So I'm either going to keep that as a 0, which since it's in the tens place would really make it 100, or I'm going to round it up to a 1, which we do. And if I round up that tens place to a 1, it makes this number now 110. Okay, I mean, I can't round off 107 to like 11, or, because that's not right. So I can either round this up to 110 or just keep it down at 100. And since it's a 7, now if it had 3 sig figs, then I would go there and I'd look at the next digit and say, okay, it's 107. But since this only had 2 sig figs. All right, let's look at a division problem. Let's look at number 66. So 66, we have 109.3758. And then we're going to divide that by 5.813. So I'm going to start by just doing the simple math. So 109.3758 and divide that by 5.813. 813 equals, ooh, let's see here. I thought there was edit, copy. Thought I could copy that. Oh, I can. Wow, that's a big number. Okay. Big number there. All right, so am I going to write all that? Here's a good example of why we have to do this in the first place. I make these measurements, which look how many decimal places there are in the number. The one measurement goes down 4 decimal places. The other measurement goes down 3 decimal places. Whatever tools I'm using to make these measurements have pretty good precision. But can I give you an answer if you say, hey, what's the, why would I be dividing? Well, if I gave you this number, 18.81572333786,341, wouldn't you be thinking, wow, man, you had a measuring tool that was super, super, super precise? Okay? No, that's not right. So instead what we do is we use our Sig Fig rules, which we know are how many significant figures are in the numbers in the problem. How many are in this first one? 7? Yeah, all 7 numbers are significant. What about in the bottom one? 4. So what should my answer have, 7 or 4? 4. All right, so let's go over here. Let's look at these numbers. Is the 1 in front significant? Yep, I'm looking for the 4th one. The 8 is significant. The next 8 is significant. The 1 is significant. Okay, that's my 4th one. So I want to round off at the 1. It's either going to be 18.81 or it's going to be 18.82. Which one do I pick? 2. Why? Look at the next digit. It's 5 or higher. So round that 1 up to a 2. Okay? Does it have 4 sig figs? It does. So we're going to practice. It's going to take some time. This is one of those things that you might not get right away. And then you practice it a little bit. And like, wait a minute, I think I might be getting this. And before you know it, you're an expert. All right?